Today under the wave topic, we will understand about the progressive wave and what is the displacement relation in a progressive waves. So, starting from our topic, in order to understand the progressive waves and their production, we can consider the production of waves in a long air-filled pipe by the movement of a piston. Let us consider the production of waves in a long air-filled pipe by the movement of a piston as shown in figure below. Let us suppose there is a pipe, and here if we have a piston P. Okay. Now the air column will be travel over here, like in this way. This is the first position of piston. This is second, and this is third one. Okay. Here are the air particles. So this is air, and we are moving piston in this direction. Here in this figure, a sound wave is set up in air-filled pipe by moving by moving a piston back and forth by moving a piston as the oscillations as the oscillations of an element of an air pipe as the oscillation of an element of air are are parallel to the direction in which the wave travels. This wave is a longitudinal wave. This wave is a longitudinal wave. Now, if we suddenly if we suddenly move a piston, if we, if we suddenly move a piston if we suddenly move a piston to the right and then to the right and then to the left, we are sending a pulse of pressure along the pipe. We are sending a pulse of pressure along the pipe. The motion of the piston to the right pushes, thus the motion of the piston the motion of the piston to the right pushes the element of air pushes the element of the air pushes the element of the air pressure there. air pressure 0. The increased pressure in this region the increased pressure in this region in this region in this region then pushes on the elements of the then pushes on the elements of air somewhat farther along the pipe. Now, by moving the piston to the left, reduces the air pressure next to it. Now, here we can clearly see. Now here we can clearly see that moving a piston, moving a piston to the left, moving a piston to the left reduces the air pressure next to it. Air pressure next to it. This causes the element of air next. This causes the air next to it move back. Air next to it move back to the left. Move back to the left, and then the further elements follow. And then the further elements follow. Thus the motion of the air and the change in air pressure travels towards the right along the pipe as a pulse. Thus, in such a way, the motion of the air the motion of the air and the change in air pressure travel towards the right along the pipe as a pulse. Right along the pipe. Now, if you push and pull on the piston in a simple harmonic manner, now if we push and pull the piston in a simple harmonic manner, a sinusoidal wave, a sinu it may be noted that the motion of the elements of air is parallel to the direction of propagation of the wave also. that the motion of the motion of the elements elements of air is parallel to the direction of air is parallel to the propagation is parallel to the direction of propagation of the wave. This motion is said to be longitudinal. This motion is said to be longitudinal, and the wave produced by such a motion is known as longitudinal waves. The sound waves produced in air are such pressure waves, and they are of longitudinal character, and they have longitudinal character. In short, we can say that in transverse waves, the constituents of the medium oscillate perpendicular to the direction of wave propagation, and in case of longitudinal waves, they oscillate along the direction of wave propagation. A wave transverse or longitudinal is said to be traveling or progressive if it travels from one point of the medium to the another. So here we can write a wave, doesn't matter it transverse or longitudinal, transverse or longitudinal, is said to be traveling or progressive if it travels from one point to. A progressive wave is to be distinguished from a standing or stationary wave. A progressive wave is said to be distinguished from a standing or stationary wave. Transverse wave travels from one end of the string to the another, and while the longitudinal waves travel from one end of the pipe to its other end. We note again that in both the cases, it is the wave or the disturbance that moves from end to end, not the material through which the waves propagate. Now, in case of transverse wave, the particle motion is normal to the direction of propagation of the wave. Therefore, as the wave propagates, each element of the medium undergoes a shearing strain. Transverse wave can therefore be propagating only in those media which can sustain shearing stress, such as solids and string, and not in fluids. Fluids as well as solids can sustain compressive strain. Therefore, longitudinal waves can propagate in all elastic media. For example, in medium like steel bar, both transverse and longitudinal waves can propagate, while air can sustain only longitudinal waves. The waves on the surface of water are of two kinds, capillary waves and gravity waves. The former are ripples of fairly short wavelength, no more than a few centimeters, and the restoring force that produces them is the surface tension of water. Gravity waves have wavelengths typically ranging from several meters to several hundred meters. The restoring force that produces those waves is the pull of gravity, which tends to keep the water surface at its lowest level. The oscillation of the particles in these waves are not confined to the surface only. So, The oscillation of the particles in these waves are not confined to the surface only but extended with diminished particles to the very bottom. The particle motion in the air waves involves a complicated motion. They not only move up, down, but also back and forth. The waves in an ocean are a combination of both longitudinal and transverse waves.